In this video, I'll be covering 2.2 skills practice, solving one-step equations. Your job is to follow along with me as I complete the odds, and then for you to try the evens on your own or with a friend. So I'm going to start with number 1. We're solving each equation, meaning we're trying to find the value of the variable. So with number 1, I have y minus 7 equals 8. The first thing I need to do is identify my variable. I'm going to highlight it, but you could circle it as well. My variable is y. That's what I'm trying to solve for. Y minus 7 equals 8. In order to find out the value of y, I need to get it by itself. And in order to get the y completely by itself, I'm going to use the idea of inverse or opposite operations to move anything else out of the way. The y is connected to the 7 by subtraction. Y minus 7 equals 8. So to undo or get rid of the minus 7, I'm going to use the inverse operation of minus, which is plus or addition. So if I add 7 to a negative 7, my goal here is that they will cancel. Negative 7 plus 7 does equal 0, which is my goal. But I have to remember the golden rule of algebra, which says what you do to one side, you must also do to the other. I'm trying to keep this equation balanced. So y minus 7, I add 7, and the 7's cancel. I'm left with just the y, equals, on this side, I have 8 plus 7, which equals 15. If you wanted to check your work, and I'm not going to make this a requirement on every problem, but you could plug that 15 in for y and make sure that it works. Does 15 minus 7 equal 8? Yes, that is true, so I know that my answer is correct. Now you should try number 2 on your own. Make sure that you're showing your work for each step, even if you can solve it easily in your head. I'm going to move on to number 3. Number 3 says negative 13 equals 5 plus x. Now my variable is on the right side, the x, and I'm trying to get it by itself. The x is connected to the 5 by addition, and the 5 is also a positive. So I want to think, how can I get rid of the 5? Well, 5, if I subtract 5, will leave me with 0. 5 minus 5 will give me 0 plus x. Well, 0 plus x is just x, which is what I want. But I have to remember, if I subtract 5 from the right-hand side, I have to also subtract 5 from the left-hand side. These 5's cancel, just as I wanted. I drop the equal sign, and then I have to solve negative 13 minus 5. Negative 13 minus 5 will give me a negative 18. Even though this looks kind of flip-flopped, negative 18 equals x, it means the same thing as x equals negative 18. If you want to write it that way, then that is fine. But either form will work. Looking at number 5, I have 98 equals b plus 34. My variable here is b. I have b plus 34. If I want to get the b by itself, I need to subtract 34 from this side. 34 minus 34 will give me 0. If I subtract 34 on the right, I must also subtract 34 on the left. 98 minus 34 will give me 64, which equals b is the only thing I have remaining on this side. Once again, if you want to flip it back to say b equals 64, that is fine. These mean the exact same thing. Looking at number 7, I have n plus a negative 28 equals 0. Don't let this confuse you. If I have plus a negative, what I'm really doing there, if I'm adding a negative, is that I'm subtracting. I like to rewrite this as n minus 28 equals 0. But all you have to know is if we're trying to get rid of that negative 28, and the opposite of a negative 28 is a positive 28. So whether you want to do plus a negative 28 or just minus 28, adding 28 is what's going to get rid of that, because a negative 28 plus 28 will equal 0 and cancel. But if I add 28 on the left, I must also add 28 on the right. I just noticed too, I forgot to identify my variable in the first step. I'm solving for n. So n, which is the only thing remaining on this side, equals 0 plus 28, which equals 28. Looking at number 9, I have negative 1 equals t minus negative 19. Now once again, I like to go ahead and simplify this. I know that if I have a minus and negative, then that is really a positive. So you could rewrite that as negative 1 equals t plus 19. If my variable is t that I'm trying to solve for, I can get rid of this 19 by subtracting it. 19, a positive 19 minus 19 will give me 0 and cancel. But if I subtract 19 from the right, I have to also subtract 19 from the left. Negative 1 minus 19 is negative 20, which equals t. Looking at number 11, I have 14 equals d plus a negative 10. Once again, you can just think of it as, how can I get rid of, if my variable is d, how can I get rid of this negative 10? Well, the opposite of negative 10 would be to add 10. But you could also simplify this and think, if I'm adding a negative, what am I really doing? I'm subtracting. So either way, I did it the other way before by rewriting it, but this way, if I want to get rid of a negative 10, I'm just going to add 10. Negative 10 plus 10 is 0, and then d plus 0 is just d. So these do cancel. But if I add 10 here, I must also add 10 here. 14 plus 10 is 24 equals d. Now we're going to take a look at number 13. 47 equals w minus negative 8. So I'm going to go ahead and simplify minus negative. What that means is we're really going to be adding w plus 8. My variable here is w. So to get the w by itself and undo a plus 8, I'm going to subtract 8. I want to think through and make sure that'll cancel. Positive 8 minus 8 will cancel. If I add 8 on the right, though, if I subtract 8 on the right, I must also subtract 8 on the left. 47 minus 8 is 39, and that's equal to w. So that is my final answer here. Moving on to the next page, we're getting into using multiplication and division on this page. So taking a look at number 15, I have 12z equals 108. My variable here is z, so I'm trying to get the z by itself. We have to remember that when there's no symbol, there's multiplication happening. So I'm going to go ahead and rewrite this just to show that we have 12 times z equals 108. Well, the opposite of multiply is divide. So if I'm trying to get z by itself, I can get rid of that 12 by dividing this side by 12. When I divide by 12, I do 12 divided by 12, which is 1, and 1z is the same thing as just a plain z. So these do cancel with each other. But if I divide by 12 on the left, I must also divide by 12 on the right. Then I want to solve 108 divided by 12, which equals 9. So z equals 9. Because this is the first one on this page, I'll just demonstrate how to check that if you want to do that on the evens. I would just plug in 12 times 9 equals 108, and I just want to verify that 12 times 9 actually does equal 108, and it does, so I know that my answer is correct. Looking at number 17, I have 18f equals negative 216. My variable here is f, and we are once again multiplying 18 times f. So in order to undo multiplication, I'm going to divide by 18. 18 divided by 18 will give me a 1f, which is the same thing as just f, so I will get it by itself. But if I divide by 18 on the left, I have to also divide by 18 on the right. A negative divided by a positive is going to give me a negative. 216 divided by 18 is 12, so I'm left with negative 12. Number 19, I have c divided by 4 equals 16, and my variable here is c. If I have c divided by 4, the opposite of divide by is multiply by. So if I have c divided by 4, what would happen if I multiply this side by 4? Well, this is kind of the same as 4 over 1. 4 over 1 is the same as 4, so if I'm multiplying fractions, I could think of it that way. I'm going to go ahead and show the longhand way to do this, and then I'll show you just the simple way. If we multiply numerators, we'd get 4 times c, which is 4c. And on bottom, I'd have 1 times 4, which is 4. When I have 4c divided by 4, these 4's cancel each other out, and I'm left with just c, which was my goal. So we could have just noticed that from the first step, and we noticed that these 4's do actually cancel. So in order to get the c by itself, I multiplied by 4, so I must also multiply by 4 on this side. So c is going to be equal to 16 times 4, which is 64. Looking at number 21, I have negative 84 equals d divided by 3. I'm trying to solve for d. I'm dividing by 3, so in order to get rid of that 3 in the denominator, I'm going to multiply by a 3. Or you could think of it as 3 over 1. If I have a 3 in the numerator, it's going to cancel with the 3 in the denominator, leaving me with just d over 1, or d. So what I did on the right was multiply by 3, or 3 over 1. So what I'm going to do on the left is multiply by 3. So 3 times negative 84 gives me a negative 252. Looking at 23, I have negative 6 equals 2 over 3z, or 2/3 z. My variable here is z. So this one brings up another rule, but it's just an extension of what we've already learned. So here I have a fraction times z. So how we would normally undo multiplication, because I have 2/3 times z, is that we would divide. So just like we did above when I had like 18f, is I divided by 18. So if I have 2/3 z, we might think to just divide by 2/3. Well, I don't know about you, but that looks a little bit crazy to have 2/3 divided by 2/3. I do not like fractions in the first place, so I definitely don't like double fractions. So let's think about how we actually do 2/3 divided by 2/3. So I'm going to take you back to middle school for a moment. I'm going to write this a different way. 2/3 divided by 2/3. In order to divide fractions, we use a rule called keep, change, flip. So what that means is I'm going to keep the first fraction as is, 2/3. Then I'm going to change the sign from division to multiplication. Lastly, I'm going to flip this second fraction upside down. So I'm going to flip the numerator and the denominator. So that'll give me, instead of 2 over 3, I'm going to have 3 over 2. Now when I multiply fractions, I multiply the tops together. 2 times 3 equals 6. And in the denominator, I have 3 times 2, which equals 6. Well, 6 over 6 just equals 1. So that was the very long way of thinking about this. But what we do when we divide a fraction by a fraction is what I'm really doing is I'm multiplying it by its opposite, which we call the reciprocal. So instead of thinking of dividing a fraction by a fraction, we can think of multiplying it by its reciprocal or its opposite. So that's what I'm going to do here. Instead of dividing a fraction by itself, I'm going to multiply by its reciprocal. So I'm going to multiply 2/3 by 3/2. Well, the 2's cancel, the 3's cancel, leaving me just with z, which is what I wanted. So if I multiplied this side by 3/2, I have to also multiply this side by 3/2. So when we multiply fraction by a whole number, I'm going to multiply the -6 times the 3. -6 times 3 is a -18. And then I'm going to divide by 2, which is going to give me a -9. Whoops. So my answer here is -9. If that process was a little tricky, you may want to rewind the video and watch it again before you try number 4. You'll be using the exact same process on number 24. Here we have number 25. I have -m/8 equals 5/8. So what I'm going to do here is identify my variable, which is m. And for this one, we could think of it in a couple different ways. Something you might notice right away is that these both have a denominator of 8. So we could just look at the numerators, but actually the way I'm going to think about this is just like I did with the division ones, like 19 and 21, where we had our variable on top divided by another number. The way that we undo division is by multiplication. So this is a -8. I want to get rid of the negative and the 8. So I'm going to multiply by a -8. If I have a -8 on top divided by -8, those will cancel and give me just one m, or m. But if I'm multiplying by -8 on the left, I also have to multiply by -8 on the right. To multiply this, I'm going to do -8 times 5, which is -40. And then I'm going to divide by 8, which will give me a -5.